Hi everyone. In this video tutorial we are going to be talking about the relative penalty steric ranking for various groups that you may see in Newman projections, okay? And being able to understand this relative steric penalty ranking is really important. It's as important as your ability to be able to identify interactions in staggered and eclipsed conformations, right? Not every steric interaction is equivalent in the amount of energy introduced to the structure. So we're going to consider the steric penalty ranking below, and I want you to commit this to memory, okay? With a couple exceptions, it's pretty intuitive. Now, your hydrogen is considered to be the least sterically penalizing. It's a very small atom. Then halogens would cause more sterics than a hydrogen. What's not very intuitive here is that the chlorine causes more sterics than the bromine, right? We know that bromine has a larger atomic radius. And the idea here is that chlorine is more electronegative than the bromine, and it has a shorter bond length. Okay, let's consider both bromine and chlorine are bonded to a carbon. Accordingly, it's the case that the chlorine, is closer to other atoms and groups, and therefore has greater steric interactions than the bromine. The bromine will have a longer bond and is further removed. If we wanted to visualize this, we could say here is a chlorine, here is its length, let's just say arbitrarily, and the bromine would have a longer bond, okay? It would be further removed from the other groups, and thus the chlorine, being closer, will have a larger steric penalty, okay? Then we have this idea of hydroxyl groups causing more sterics than your halogens, okay? When you get to your carbon groups, your methyl, ethyl, isopropyl, and tert-butyl groups, we see an increase in the steric penalty, and that is related to an increase in chain length and the extent of branching, okay? From methyl to ethyl, we see an increase in steric penalty. The chain is elongating. When we go from ethyl to isopropyl, here now we have a carbon bonded to two methyl groups. This is an isopropyl group. That is a lot more sterically penalizing than an ethyl. And we'll see a huge increase in sterics when we look at the tert-butyl group. The tert-butyl group has a carbon bonded to three other methyl groups. Tert-butyl groups cause an enormous amount of sterics. Okay, enormous. I can't stress that enough. What did I say? Enormous. Tert-butyl groups are extremely sterically penalizing. Okay, so we have to know the steric penalty ranking because when we go to look at different conformations and rank them in relative energy from least stable to most stable, we not only have to identify what Gauss interactions there are, what eclipsed interactions there might be, but what types of atoms and groups are interacting and the relative steric penalty of those interactions. Okay, we are going to be getting into that in the next couple videos.